The future of American air combat may depend not only on building more advanced aircraft, but on how quickly new autonomous capabilities can move from software development to the battlefield. Northrop Grumman is positioning its YFQ-48A Talon Blue autonomous wingman at the center of that transformation, linking the aircraft to a broader initiative known as Project Talon. Rather than developing a single unmanned combat aircraft in isolation, Project Talon is designed as a connected ecosystem, combining autonomy software, flight testing, and modular uncrewed aircraft. The objective is to shorten the time required to develop new autonomous capabilities, test them in the air, and ultimately integrate them into operational combat networks. At the heart of this approach are two systems. The first is Talon IQ, a flying test environment designed to integrate and evaluate autonomy software. The second is the YFQ-48A Talon Blue, an autonomous wingman intended to operate alongside crewed combat aircraft. Together, they form a development pathway in which new software and mission capabilities can be tested aboard Talon IQ before potentially being transferred to operational platforms such as Talon Blue. The concept comes as the U.S. Air Force accelerates its Collaborative Combat Aircraft, or CCA program. These autonomous aircraft are expected to operate alongside crewed fighters, adding sensors, weapons, and additional combat mass in heavily contested environments. Northrop Grumman participated in the initial CCA competition, but General Atomics and Anduril were selected to move forward with their YFQ-42A and YFQ-44A designs. Northrop Grumman subsequently reworked its approach. The resulting Talon Blue design places greater emphasis on a lighter, less complex airframe, faster manufacturing, and an architecture capable of adapting to different mission requirements. According to figures released during the initial presentation of Project Talon, the aircraft uses around 50% fewer parts than Northrop Grumman's previous CCA proposal. It is approximately 1,000 pounds lighter and could be produced around 30% faster. Composite materials and components derived from existing designs are also intended to reduce development costs and production lead times. But the aircraft itself represents only part of Northrop Grumman's strategy. Talon IQ provides the experimental backbone. Based on the scaled composites model 437, the aircraft is approximately 12.5 meters long with a similar wingspan. It is powered by a Pratt & Whitney PW535 turbofan, producing around 3,400 pounds of thrust. The aircraft has a maximum takeoff weight of roughly 4,536 kilograms and a payload capacity of approximately 907 kilograms. Its internal weapons bay was originally designed to accommodate two AIM-120 air-to-air missiles, while the Model 437 has a stated endurance of up to 6 hours and a range of around 3,000 nautical miles. More importantly, Talon IQ provides an open architecture where government teams, industry partners, and third-party developers can test autonomous software in flight. That could allow new capabilities to be evaluated and modified without redesigning an entire combat aircraft around each emerging requirement. Talon Blue would then provide a modular operational airframe designed from the beginning for reduced production complexity and faster manufacturing. Northrop Grumman is entering a rapidly developing competitive environment. General Atomics continues work on the YFQ-42A, while Anduril is developing the YFQ-44A. In July 2026, the U.S. Air Force announced that a YFQ-44A had fired an AIM-120 air-to-air missile against a digital target over the Mojave Desert, demonstrating further progress in weapons integration. Elsewhere, Boeing continues development of the MQ-28 Ghostbat, while Lockheed Martin is advancing its Vectis concept. The competition is therefore expanding beyond individual aircraft. It increasingly involves autonomy software, open architectures, manufacturing speed, and the ability to rapidly integrate new technologies from multiple suppliers. And that may ultimately be the most significant aspect of Project Talon. For the U.S. Air Force, combining crewed fighters with autonomous aircraft could provide greater combat mass against adversaries protected by sophisticated air defense networks and electronic warfare systems. For Northrop Grumman, Talon Blue represents an attempt to compete in that environment not simply by producing another autonomous wingman, but by creating a development system capable of evolving alongside the mission. As collaborative combat aircraft become increasingly important to air power strategies in the United States and beyond, The decisive advantage may no longer come from the performance of a single aircraft. It may come from how quickly new software, sensors, weapons, and autonomous capabilities can be tested, integrated, and sent into combat.